Hi there. For my next clock, I wanted to make something that was visually simple, but also as accurate as possible. And I thought those two goals might be in conflict, but actually they worked out okay. So let me show you what I've come up with. It's a free swinging pendulum design with a fused quartz rod, impulsed by two electromagnets up at the top, with barometric pressure compensation, a display screen. This one's just temporary, it'll get a touchscreen display. Fine adjustment is on a weight tray in the middle of the rod with these little weights. Down at the bottom we've got the bulb, and beneath that we've got two-part temperature compensation. Top part compensates for the residual expansion of the fused quartz rod. The second part compensates for the expansion of the stainless steel threaded tip. And then down at the bottom we've got a tip on it which triggers a beam break photosensor, and that's what detects the motion of the pendulum. That's what drives the timing for the impulses from the electromagnets and also the display timing. The next step is to make the barometric compensation mechanism and 8 little aneroid cells. And they turn into a pair of aneroid assemblies, 4-stack assemblies, which will have different weights that I can use to vary the amount of barometric compensation that I'm getting. The small adjustment weights were cut out of a sheet of copper. All the components of the pendulum are now made, so it's time to put them together. So what we have is the hanger bolt that holds the top block, which holds the suspension spring connected to the lower suspension block. That is through pinned into the top of the quartz rod, quartz tube. We have this assembly which picks up the impulses from the electromagnets that are going to give the pendulum its impulse to keep it going. This support bar holds the anaerobic cells and their weights to do barometric pressure compensation. And then there's a weight table in the middle of the tube with its little weights to do fine adjustment. And all of these three are secured onto the glass tube with soft tip set screws to hopefully avoid cracking the glass. Down at the bottom we have the bob, which is supported on its small quartz support tube, which sits on top of a stainless steel tube, stainless steel bar. There's also a brass bar. Rating nut at the bottom allows me to adjust the position of all of this, and then a tip at the end to pick up the beam brake photo sensor. So now let's put it all together. And now it's time to get the electronics to work. And with the addition of the wall mounts, that completes the construction. Now that it's hanging on the wall, I can start doing some test runs and get a look at what sort of accuracy we can get from this. And from those initial runs, I can collect data like this, which shows the clock's basic run rate information, how it's affected by temperature and pressure and humidity, and also some information about what might be possible if the compensations were optimally adjusted. And this is suggesting that with proper optimization of the compensators, this might be possible to get within 1 second a day accuracy, which would be great. I'd be really pleased with that. So there you have it, a simple but accurate free swinging pendulum clock design. Thanks for watching.